we have discussed on the reason why we do the multi-stage. So next we consider this connection of the multi-stage. So the connection of the multi-stage is shown in this very simple circuit diagram. So this triangular shape component, this is the general symbol for the amplifier. So we have amplifier 1, amplifier 2 and amplifier 3. So the general connection will be the output of the amplifier 1. So this is the output for the amplifier 1 will become the input of amplifier 2. Okay, so the output of one amplifier is the input of the next amplifier. So this is what we call a cascading. This is the cascading. So the word cascading means that the output of one amplifier will become the input of the next amplifier. Okay, when you do this cascading, the overall voltage gain is determined by the product of the gain of the individual stage. So for example, if we know that the gain of the amplifier 1 is A1, A2 is the gain of amplifier 2, A3 is the gain of amplifier 3. So the total gain of this amplifier is A1 times A2 times A3. So the product of the gain. So this is A1 times A2 times A3. Okay, and then I need you to take note that this configuration or this explanation is when we consider the ideal voltage amplifier. So ideal voltage amplifier, the Zi in infinity, Z out is 0. So means that all the voltage will be delivered to the input, and then the all the generated output inside the amplifier will be delivered to the output terminals. So there will be no loss in terms of due to the what we call a loading effect. Okay, for this example, given all the voltage at the input and output of the amplifier is given, so you can actually calculate the individual voltage gain. So A1 we get is 40, 36 millivolt over 900 microvolt, 40, and A2 with the same calculation will get 34.722, and A3 will get 16.8. So the total voltage gain is 23,333. Okay. The total voltage gain can also be calculated. The total voltage gain by consider the final output divided by the initial input. So this is 21 divided by 900 microfarad. So this is okay. So this is same, So this is the same. Okay. Another way to look at this to solve this type of problem is if you label this is V3 and then this is label this is V out 2, and then this label this one is the let's say I put here this is V2. So actually you can you can make the relationship V3 is equal to A3 V out 2. Okay, and then what is V out 2? V out 2 is A2 V2. What is V2? V2 is A1 V1. Okay, so you have the V3 over V1 is equal to A3, A2 and A1. So this is the same with the product of all the gain. Okay, so let's consider the non-ideal voltage amplifier model. So the non-ideal voltage amplifier model should have the input impedance. So this is the Z in, and then it also have the this is your AVOC, V in, also have the Z out. Okay, so we can consider a cascaded three-stage identical amplifier. So identical amplifier means all the three-stage amplifier will have the same gain and the same input and output impedance. So the gain is, the AVOC is 18, okay, and then the input impedance is 33 kilo ohm, and output impedance is 10 kilo ohm. Okay, okay, and then at the input of the cascaded the multi-stage amplifier, there is the source connected to the input, and the source is 5 milli VRMS with the resistance 42 kilo ohm. 42 kilo ohm. And then at the end of the output of the multi-stage is connected to 2.2 kilo ohm load. So the question is calculate the total voltage gain and the voltage across the load. Okay. So based on this statement, you can draw the equivalent circuit. You can draw the equivalent circuit of the multi-stage. So we start from the source. We have the source here. The source is 5 milli VRMS, and then there is the R signal is 42 kilo ohm. Okay, and then we go to the first amplifier. So the first amplifier, this is the Z in is 33K. This is, let's say this is VI1. This is 18 VI1. Okay, so this is 18 VI1, and then the Z out is 10K, and then this is connected to the next amplifier, the next stage. This is ZI. ZI is 33 kilo, and this is VI2. This is 18 VI2, 10K, this is 33K, and then this is the input of the third amplifier, the third stage. This is 18 VI3, this is 10K. Okay, lastly, so we have the first amplifier, second amplifier, third stage amplifier, and at the end is connected to the load. The load is equal to 2.2K. Okay, so the question is calculate the total gain. So this is Vs. Okay, let's say the voltage across the load is V out. So we want to calculate the AVS equal to V out over Vs. Okay. To calculate this one, we start from the derivation of the V out. So V out is the voltage division between this 2.2K and the 10K. So the source is 18 VI3. So V out is 2.2K divided by 2.2K plus 10K, 18 Vi3. So this is equal to 3.25 Vi3. So and then you go to what is Vi3? Vi3 is the voltage division between 33K and 10K. So this is 3.25 Vi3 equal to 3.25 33K over plus 10K 18 Vi2. So this will give you 44.895 Vi2. And then 44.895 Vi2 equal to, the Vi2 is division between 33K and 10K. So this is the same equation with the above line, but now this is 18 Vi1. Okay, this will give the total is 620 Vi1. Okay. And then Vi1 is division between the Z in and out signal. So this is Q and this is the Vs. So lastly, you will get 272.8 Vs. So the V out over Vs is equal to 272.8. So this is the answer. The next question is determine what is V out. So the given the Vs is 5 milli VRMS. So V out is equal to 272.8 times 5 milli VRMS. So this is equal to 1.36 volt RMS.